What if everything we know about black holes is only half the story? For decades, scientists thought black holes were just cosmic death traps, swallowing anything unlucky enough to cross their path. But new research suggests something much stranger. Instead of being dead ends, black holes might actually be doors to other universes. And the evidence behind this isn't science fiction, it's real, it's disturbing, and it changes the way we look at reality itself. Imagine watching a star explode twice. That's exactly what astronomers saw in 2014 when they studied a supernova 500 million light years away. Normally, when a star dies, it collapses and explodes once, but this one erupted, went quiet, then exploded again with even more energy. Scientists call it IPTF14HLS, and they still don't fully understand it. One theory is that instead of collapsing completely, the star's core interacted with a black hole, briefly vanishing into what some think could have been a passageway before re-emerging to fuel the second blast. If true, it means the black hole didn't just consume, it spit something back out, like a doorway to somewhere else. What if every black hole has a twin? In 2014, theoretical physicist Carlo Rovelli proposed that black holes might eventually transform into something called white holes. Unlike black holes that only pull things in, white holes are predicted to push everything out. According to Rovelli's math, when a black hole reaches a certain point, it doesn't stay locked forever. Instead, quantum effects could flip it into a white hole, blasting its contents back into another region of space or even into another universe entirely. This is one of the strongest scientific suggestions that black holes could act as cosmic portals instead of cosmic graves. At the center of our own galaxy sits Sagittarius A, a supermassive black hole 4 million times the mass of the Sun. In 2019, telescopes caught it flaring with unprecedented brightness. For a moment, Sagittarius A shone 75 times brighter than usual, then quickly dimmed back down. No one can explain why. Some scientists think the black hole swallowed a passing object. Others wonder if it was a glimpse of energy leaking from somewhere else, hinting that the heart of the Milky Way could be connected to something beyond our universe. Before his death in 2018, Stephen Hawking left behind a final paper that shook the scientific community. In it, he argued that black holes might not be as final as we think. Instead of completely trapping information forever, they could store and release it in ways that hint at a hidden universe. Hawking believed that the event horizon, the point of no return around a black hole, might be more like a hologram. Information could be smeared across it, waiting to reappear somewhere else. If he was right, then black holes aren't just destructive, they're like gateways. It sounds like science fiction, but wormholes are a real solution to Einstein's equations of relativity. In 1935, Albert Einstein and Nathan Rosen proposed that black holes might be linked to something called Einstein-Rosen bridges. In theory, these bridges could connect two distant regions of space, or even two separate universes. For decades, it was just math, but in the last few years, physicists running simulations on quantum computers found that particle interactions behaved exactly like tiny wormholes. If wormholes can exist on a small scale, it raises a disturbing question. Are the supermassive black holes we see across the universe actually gigantic portals? Have you ever felt like time was slipping away faster than usual? Near a black hole, that sensation becomes literal. As you approach the event horizon, time itself begins to slow down relative to an outside observer, a phenomenon known as gravitational time dilation. For someone falling into a black hole, the journey might seem to take just seconds, while years pass in the outside universe. Have you guys ever seen Interstellar? Because that movie, I'm always thinking about it. This extreme stretching of time isn't just a quirky side effect. It is a direct consequence of the immense gravitational pull warping space-time. In theoretical models, this means that the interior of a black hole is a realm where the very flow of time is distorted beyond recognition. Such effects have been confirmed in weaker gravitational fields, like near Earth, albeit on a much smaller scale, but near a black hole the difference becomes almost surreal. It is a humbling reminder that time, a constant in our everyday lives, is actually a flexible dimension that can bend and twist in the presence of enormous gravity. What if the core of a black hole isn't a single smooth singularity at all? Enter the fuzzball theory, a radical idea from string theory that suggests black holes might be composed of tangled loops of energy and matter. Instead of an infinitely dense point, a fuzzball is a chaotic, stringy conglomerate that replaces the traditional notion of a singularity. This theory attempts to resolve some of the paradoxes of black holes, like the loss of information, by positing that the interior is a complex, ever-changing landscape of quantum states. Although still highly theoretical and not yet proven, fuzzball models offer a tantalizing glimpse into how quantum gravity might work in extreme conditions. They challenge our classical intuitions and propose that the mysteries of black holes are not about empty voids, but about intricate, dynamic structures at the quantum level. This perspective is as fascinating as it is unsettling, hinting at a universe where the very building blocks of reality are far more tangled than we ever imagined. Can information be truly lost? This question lies at the heart of the black hole information paradox, a puzzle that has confounded physicists for decades. According to quantum mechanics, information about a system's state should never vanish, yet when matter falls into a black hole, it appears to disappear forever. This contradiction pits the principles of quantum theory against general relativity and has led to heated debates and ingenious hypotheses. Some suggest that the information might be preserved on the event horizon in a holographic form, while others argue that our understanding of quantum mechanics needs a radical overhaul. What makes this paradox so terrifying is that it shakes the very foundation of physics, forcing us to question whether the universe is fundamentally deterministic or if some secrets are lost in the cosmic abyss. What happens when a black hole spins? Most black holes in nature are not static. They rotate, and this spin leads to a surprising twist in their internal structure. Unlike the spherical symmetry of a non-rotating black hole, also known as a Schwarzschild, a rotating black hole, also known as a Kerr, is predicted to contain a ring-shaped singularity. This ring singularity gives rise to some bizarre theoretical phenomena, such as the possibility of closed time-like curves, paths in space-time that loop back on themselves and, in theory, could allow time travel. While these ideas remain highly speculative and are likely artifacts of our current mathematical models, they underscore the complexity and richness of black hole physics. The Kerr solution also introduces an inner horizon, a secondary boundary that separates different regions of the black hole's interior. This inner structure could be susceptible to instabilities that lead to unpredictable behavior, adding another layer of mystery and another layer of danger. In essence, the rotating nature of black holes doesn't just make them more dynamic, it transforms them into cosmic maelstroms with secrets that challenge our understanding of time, space, and causality. Could black holes be the key to unlocking the ultimate laws of the universe? While it might sound like the plot of a sci-fi thriller, black holes serve as natural laboratories for testing the boundaries of physics. Their extreme conditions, where gravity, quantum mechanics, and thermodynamics intersect, offer clues about how to reconcile the seemingly incompatible theories of general relativity and quantum mechanics. Experiments like gravitational wave detections from black hole mergers and studies of the cosmic microwave background are gradually peeling back the layers of mystery. Researchers are also exploring advanced mathematical models and computer simulations to understand the quantum nature of space-time in these extreme environments. Every new theoretical insight or experimental breakthrough brings us one step closer to a theory of everything, a single framework that could explain all fundamental forces. It's both an exhilarating and a daunting prospect, as it means we are on the brink of rewriting the rules of physics as we know them. Black holes, with all their terrifying secrets, might just hold the answers to the deepest questions about our universe.
Is there anything more mysterious and and foreboding in the vastness of space than a black hole?
Scientists still aren't sure exactly what happens to the material that gets sucked into these things, and hopefully we'll never have to find out firsthand. Anyway, sit back, try to relax, as we bring you some of the scariest black holes ever observed.
Recently discovered within a dwarf satellite galaxy that goes by the name of Leo 1. Now, a satellite galaxy basically just means it's a smaller galaxy caught in the orbit of our own galaxy. Think satellites orbiting Earth, but scaled way up. The black hole was discovered in late 2021 by an independent team of astronomers who had been scanning the small galaxy in order to measure its levels of dark matter. Upon closer inspection, they found what they considered to be an unusually small amount of dark matter, but as I mentioned earlier, an unusually large black hole sitting at the center of the galaxy. You see, compared to the Milky Way, the Leo 1 is considered to be quite tiny. But the kicker here is that the black hole discovered within its parameters is almost as large as one found in our very own much larger galaxy, meaning this is an unprecedented mass ratio that up until now had never been seen before. Now, don't worry too much though, as this particular black hole is currently 830,000 light years away. But that being said, if Leo 1 were to begin sinking into our own galaxy, it is entirely possible that this recently discovered black hole just might collide with one of the Milky Way's very own, resulting in, well, let's just say it wouldn't be pretty.
So my first pick is the very recently discovered Scary Barbie. Imagine if we all met our end getting swallowed up by a black hole named Scary Barbie. What would the extraterrestrials watching us think of that? Looking at us through their highly advanced telescopes, light years away. Planet designated Earth has undergone absorption into cosmic singularity, denoted as black hole, bearing nomenclature akin to one of their curious humanoid toy entities known as Barbie. And they'd all burst out laughing. I feel like we're kind of setting ourselves up for failure with that one. But this Scary Barbie formation is no joke. Scientists first observed this supermassive black hole devouring a star, sucking it in and ripping it apart in a process known as spaghettification. Apparently, Scary Barbie really suits its name. It's super vibrant, luminous. Danny Miloslajevic, an assistant professor of physics and astronomy, said that it is, quote, the most energetic phenomenon I have ever encountered. Apparently it's brighter than 1,000 supernovas combined, and supernovas are some of the most luminous objects in the sky. Another fascinating thing about this thing is that it's classified as transient, meaning it can show up or disappear not over the course of centuries or millennia, but in mere hours or days. Now, most transients like this aren't around for very long, maybe a handful of months at most, but Barbie's been around longer than any other observed transient and is apparently still evolving.
Well, that's one Barbie I definitely don't want to party with. Next on the list, we have Sagittarius A. And before you switch the video, no, I'm not talking about astrology, but rather the supermassive black hole that sits right smack bang in the center of the Milky Way. You know that place where Earth is? Okay, before you start doomsday prepping, I will let you know that this particular black hole is not actually super active, meaning it's not gobbling up the stars and planets around it nearly as fast as some of the other black holes discovered in recent years. However, it is growing, more so in relation to the natural growth of the galaxy, meaning its size in relation to the size of the Milky Way has pretty much remained the same. So again, no need to panic, for now. While Sagittarius A is the largest black hole within our own galaxy that we're currently aware of, I'm happy to report that it's not the closest, as it sits some 26,670 light years away from Earth. However, having said that out loud, I'm not really sure it's all that comforting.
Alright, next up on the list is M87. This one sits right at the center of the galaxy Virgo A. So luckily, it's not anywhere near us, but the universe can be a pretty unpredictable place. That's all I'm gonna say. I'm not a scientist, but when I read that this thing is billions of times larger than our sun, yeah, it kind of freaks me out a little, right? In fact, it's about 6.5 billion times the size. I don't even know how to visualize a number that big. Now, what makes this black hole particularly famous is that it was the first black hole ever to be directly imaged by the Event Horizon Telescope in 2019. The event horizon is the boundary around a black hole where beyond it, nothing can return. The image showed a dark shadow surrounded by a ring of bright, hot gas swirling around the black hole. The dark shadow is where the light gets trapped by the black hole's gravity.
In 2019, astronomers announced something that shocked even the most experienced astrophysicists: the discovery of LB1, a black hole sitting quietly in our galaxy about 15,000 light years away. At first glance, it looked like just another stellar black hole, the kind formed when a massive star collapses under its own gravity. But the mass didn't add up. LB1 was measured to be about 70 times the mass of our sun. That number may not sound outrageous on its own, but based on everything we know about how stars live and die, a black hole this size shouldn't exist. Stars that big are expected to shed much of their mass before collapsing, leaving behind a black hole no larger than 20 to 30 solar masses. The discovery of LB1 blew a hole in those models. Some scientists tried to recheck the math, wondering if the measurements were wrong. Others suggested it might be two smaller black holes orbiting each other, giving the illusion of one giant. But there's also a stranger idea. Some theorists believe LB1 may not be a standard black hole at all, but rather an exotic object, something that mimics the appearance of a black hole while actually connecting to another region of space or even to a parallel universe. The unsettling part is that this object is right in our galactic neighborhood. It isn't sitting billions of light years away. It's relatively close by cosmic standards, quietly breaking the rule of physics we thought we understood. Its existence forces us to admit that either our theories about stellar death are incomplete, or we've stumbled across something far stranger than we ever imagined. There's one rule about black holes that's been drilled into us for decades. Once something crosses the event horizon, it's gone forever. But in 2021, astronomers observed something that seemed to bend that rule. Using the European Southern Observatory's Very Large Telescopes and NASA's New Star Space Observatory, they detected beams of X-ray light coming from behind a supermassive black hole. That should be impossible. Here's what happened. The black hole was actively feeding, pulling in gas and dust. As this material swirled around it, it released bursts of X-ray light. Some of those X-rays appeared to be shining directly from behind the black hole, hidden from view, yet the telescope saw them. The explanation? Well, the black hole's gravity was so extreme that it bent space itself, warping the path of light around its edges and revealing what was otherwise invisible. Physicist Dan Wilkins, one of the lead researchers, admitted that while this was a predicted effect of Einstein's relativity, it was one of the first times humans had ever witnessed it in action. On one hand, it confirmed that relativity is spot on even under extreme conditions, but on the other hand, it raised an eerie thought. If black holes can literally bend reality and let us see around corners of the universe, what else could they be doing behind the curtain? If light can slip past the abyss in this way, could other stranger forms of matter or energy escape too, perhaps in places that we can't even comprehend? At the smallest scales of reality, things stop behaving normally. Physicists call this level quantum foam. Instead of space-time being smooth and continuous, it's thought to bubble and fluctuate wildly, with tiny temporary distortions popping in and out of existence. Black holes, with their extreme density and gravitational pull, may interact directly with this quantum foam in ways we can't yet measure. Physicist Lee Smolin took this further with the bold idea in the 1990s. What if every black hole creates a new universe inside it? He called the theory cosmological natural selection. According to this idea, when matter collapses into a black hole, it doesn't just vanish. Instead, it seeds a brand new universe with slightly different physical laws. That universe then evolves and in turn forms its own black holes, creating even more universes. In this picture, our universe might simply be one child in a vast family tree of universes, each branching out of black holes in its parent. It's a strange but strangely elegant concept, and it means when we look at a black hole, we're not just staring into a cosmic graveyard, we could be looking at a cradle, the birth point of entire realities that exist beyond our own, forever unreachable but constantly forming in the shadows. Few problems in physics are as unsettling as the firewall paradox. It starts with a simple question: what actually happens at the edge of a black hole. According to Einstein's general relativity, if you were unlucky enough to fall in, you wouldn't notice anything special when you crossed the event horizon. You'd just keep falling, stretched thinner and thinner until you were crushed at the core. But quantum mechanics doesn't agree. In the quantum view, information can't just vanish. Something must mark the crossing of the horizon. That something, according to some physicists, would be a blazing wall of high-energy particles, instantly incinerating anything that touched it. The trouble is, both theories are highly respected, both are supported by evidence, and both completely contradict each other in this case. To resolve the paradox, some researchers have suggested that maybe we're asking the wrong question. Maybe black holes don't sit neatly inside our universe at all. Maybe they're connected to another domain where these contradictions don't apply, a place where relativity and quantum mechanics merge seamlessly. If that's true, then the edge of a black hole isn't a wall or a smooth crossing, it's actually a boundary, marking the point where our reality ends and another begins. That possibility makes the firewall paradox not just a mathematical puzzle, but a potential signpost to other universes. In 2015, detectors on Earth picked up ripples in space-time itself. These were gravitational waves caused by two black holes colliding over 1 billion light-years away. But here's the strange part. Some physicists analyzing the data argued that the signal contained echoes, tiny aftershocks that shouldn't exist if black holes are just pits of nothingness. Those echoes suggest that the collision may have opened a doorway, or at least revealed new physics beyond our universe. The possibility shook the field of astrophysics, because if the echoes are real, it means black holes are not just collapsing matter, they're signs of something much bigger.
Today we're diving into one of the universe's most mysterious and yes, downright eerie phenomena. Black holes are notorious for their extreme gravitational forces and the mind-boggling predictions of physics they inspire. While we can't peek inside these cosmic beasts directly, our best scientific theories give us fascinating clues about what might be lurking in their depths. So buckle up as we explore spine-chilling yet scientifically grounded tales from the edge of our understanding. Have you ever wondered what happens when matter is crushed beyond all limits? At the very heart of a black hole lies the singularity, a point where density becomes infinite and our conventional laws of physics break down. According to Einstein's theory of general relativity, all the mass of a black hole is squeezed into an extremely small point, creating gravitational forces so extreme that space and time themselves are warped into oblivion. What makes this even more mind-bending is the BKL conjecture, which suggests that as one approaches the singularity, the behavior of space-time becomes chaotically oscillatory. While we haven't observed this directly, mathematical models paint a picture of a place where the rules we rely on crumble into a dizzying dance of chaos and compression. This isn't just a quirk of theory, it's a window into the limits of our understanding, where the fabric of reality is torn asunder. Imagine being stretched out like a piece of spaghetti. Sounds like a scene straight out of a science fiction, right? But spaghettification is a real, horrifying phenomenon predicted to occur near a black hole's event horizon. As an object, or an unlucky astronaut, gets closer, the gravitational pull on its nearer side becomes vastly stronger than on the farther side. This difference, known as tidal force, elongates and thins the object until it's ultimately ripped apart. Laboratory experiments with analog materials can mimic this effect on a very tiny scale, and computer simulations give us a glimpse into this destructive ballet. What's particularly chilling is that the process isn't gradual, it can happen in a matter of seconds once you cross a certain threshold. Even though this violent stretching is a prediction of relativity, it highlights just how brutal the environment around a black hole really is. Have you ever wondered what it feels like to cross an invisible boundary from which there is no return? The event horizon of a black hole is exactly that, a point of no escape where the gravitational pull becomes so overwhelming that not even light can flee. To an external observer, objects nearing the horizon seem to slow down, their light stretched into eerie red hues as they fade into darkness, but for someone falling in, time feels almost normal until the tidal forces accelerate dramatically. This bizarre dichotomy, where two observers experience reality in such
much different ways challenges our very notions of time and space. The event horizon isn't just a physical boundary, it's a conceptual frontier that forces us to rethink what it means for something to exist when the familiar rules of physics are thrown out the window. Could the edge of a black hole be a wall of fire? That's the burning question raised by the firewall paradox, a modern puzzle at the intersection of quantum mechanics and general relativity. Some physicists argue that instead of a smooth passage, the event horizon might be surrounded by a searing barrier of high-energy particles. This so-called firewall would incinerate anything daring enough to cross it, contradicting the long-held belief that an observer falling in would notice nothing unusual at the horizon. While the idea is highly controversial and remains unresolved, it has sparked debates about the very nature of information and how it survives, or doesn't, in the face of extreme gravitational forces. The firewall paradox forces us to confront uncomfortable questions. Could our understanding of space-time be so incomplete that the boundary of a black hole isn't gentle at all, but a blazing, destructive wall? Did you know that black holes aren't eternal? Stephen Hawking's groundbreaking work in the 1970s revealed that black holes can emit radiation, a phenomenon now known as Hawking radiation. This process arises from quantum fluctuations at the event horizon, where particle-antiparticle pairs pop into existence. Occasionally, one of these particles escapes, leaving its partner to be swallowed, gradually sapping the black hole's mass. Over unimaginably long periods, this could lead to the complete evaporation of the black hole. What's terrifying here isn't just the idea of a black hole slowly dying out, it's that this process challenges our understanding of energy conservation and information in the cosmos. Though detecting Hawking radiation remains a significant experimental challenge, its theoretical implications continue to stir debates about the fundamental laws governing our universe, reminding us that even the darkest corners of space have a finite lifespan.
Now this next one hits just a bit closer to home than the rest of them, and by that I mean it's quite literally the closest black hole to Earth that has been discovered to date. Going by the name of Gaia BH1, when it was first discovered in 2022, scientists were both shocked and bewildered, as this black hole sits 10 times closer to Earth than previous record holder, sitting at a mere 1,500 light years away. And if that weren't already uncomfortable enough, the Gaia BH1 has a mass of 9.62 times the mass of our Sun, which of course gives it a large gravitational pull. In fact, our bewilderingly close dark companion actually has a star-like sun of its own that orbits around its massive parameter. While scientists deem that this giant is not of any immediate threat, it should be noted that its proximity to Earth alone makes it an incredibly ominous neighbor, as should the black hole decide to change its predominantly dormant ways, it could spell disaster for us all. What would you do if you knew it was your last day on Earth?
Alright, this next one's pretty alarming as well. Its designation is J114447.77-4. It goes on and on, but it's J1144 for short. Just still not a very catchy name either. This one happens to be the fastest growing black hole the past 9 billion years. That's the alarming part, in case you weren't sure. So what does this thing's diet consist of? Well, it devours the equivalent of one whole Earth per second. It was first observed by scientists in June of 2022, and it was 3 billion times larger than our sun and just continues to grow. This also makes it 500 times bigger than our very own Sagittarius A, discussed earlier. J1144 is also 7,000 times more luminous than all the light in the Milky Way combined. It's so bright that you don't even need to be a pro astronomer to see it. Just grab a telescope that's at least 30 to 40 centimeters across. Try that. Let us know how it goes for you in the comments.
And of course we had to include none other than Gaia BH2. Sound familiar? Holding the record for the second closest black hole to Earth, Gaia BH2 comes in at just about 3,800 light years away and just about 2,200 light years away from Gaia BH1. With a mass of 8 times that of our Sun, we are counting our lucky stars that as of most recent monitoring, Gaia BH2 appears to be mostly dormant. But hey, New year, new black hole, right? Now, because of its proximity to Earth, along with its proximity to our other big scary friend, Gaia BH1, while it's not probable, the risk of Gaia BH2 ending the world lies in the possibility that the two mass-packed giants collide. And if that happens, well, simply put, the violent process would send ripples surging through the very fabric and time of space. I mean, I'm all for a day out on the water, but that's one riptide I definitely wouldn't want to get caught up in.
All right, next we have V404 Cygni. So this is a binary system in space that includes a black hole and a companion star. This system became kind of well known in the scientific world because of some pretty intense and honestly spooky behavior. So back in 2015, V404 Cygni was especially active. NASA's SWIFT satellite detected it emitting powerful X-ray bursts. These bursts were so strong that they temporarily made V404 Cygni one of the brightest objects in the sky. Now, what makes this thing intriguing, but kind of scary to imagine, is the process behind this burst of activity. As material from the companion star gets too close to the black hole, it doesn't fall in smoothly. Instead, it forms a hot, swirling disk around the black hole, and during this process, it releases a huge amount of energy, including X-rays. And these X-ray flares are kind of like space fireworks. That meant the black hole was on a feeding frenzy of sorts.
Get ready, because next on the list we have none other than TON 618, aptly named as it is the largest black hole to have ever been observed by scientists. Discovered in 1957, TON 618 sits at a comforting 10.37 billion light years away from Earth. So while not the furthest, that title goes to an unnamed abyss, which sits at an even more comfortable 31 billion light years away from Earth, the TON is still pretty far. The bone-chilling mass-hoarding phenomenon was first observed from an observatory in Mexico, and because of its active nature, it has been closely monitored since then. Now, I bet a ton of you watching are just dying to know how big this thing really is. Well, okay. TON 618 is estimated to be a mighty 66 billion times the mass of our sun, which means that even though it is pretty far away, it could just as easily swallow our entire solar system whole without even so much as a drink of water if it really wanted to. The fact that we've never actually seen this happen might sound comforting, but the truth is, that means we really just don't know what we're up against.
Alright, and finally we have Cygnus X1. This has to be one of the most famous black holes ever observed. It was discovered during a rocket flight in 1971. Rush made a song about it, because of course they did. Like, that news came out and Geddy Lee was like, we have to write a song about this. You could say Rush, I guess, wrote the song in a hurry. It's also been referenced in Futurama and Godzilla. Cygnus X1 is another duo featuring a black hole and a massive companion star. This one was one of the first strong black hole candidates ever identified. Cygnus X1 consists of a star about 20 times more massive than our sun, and right by it is a black hole. The black hole is stealing material from the star, forming a swirling disk of super hot gas around it. So I could see the jokes in the comments. Super hot gas, black hole. The material swirling into the black hole gets incredibly hot, emitting X-rays that can be detected by telescopes in space.